Hello, today we are beginning Chapter 9 about sequences and series. We're going to start with 9.2 arithmetic sequences. You guys will be able to define, identify, and apply arithmetic sequences. So, a few things to start. I have an example. I want us to find the next two terms in this sequence. Now, you've done this stuff for a really long time. You go ahead and just find how much we add here. Find how much you add between the next two. Thankfully, they're the same thing. So we know for our next term, we must also add 4. And then same thing for the last term, so we end up getting 15 and 19. Now we could continue to do that to find any term down the line, the 20th, the 100th, so on and so forth. But we will discuss this equation that can tell us what the 20th, the 100th, the 1000th term is much faster than just adding 4 that many times. Okay, so before we do that though, we need to talk about what each of these variables means, okay? So we have a sub 1. This just means the first term. So in our case over here, a sub 1 is 3. Okay, n is the number of terms. So if you were trying to find, say, the 100th term, n would be 100. And d is the common difference. So in our example, d is plus 4. All right? So if we use this equation, we're going to find the 5th term. I know we already found the 5th term, but we're going to make sure that this equation works and we understand what's going on, okay? So we're just going to plug in 5 for n. So we know our first term is 3. The nth term that we are trying to find is 5. Minus 1 times the difference is 4. So we can go ahead and simplify within the parentheses and then multiply by 4. So you'll notice our 5th term is 19, which is what we had found by just adding 4. Meaning you could find, say, the 80 term 80, and you would get that number, okay? So the arithmetic nth term sequence just gives us what number is that term in the sequence. Now, one other thing I want to go over is just a plain old average. So if you are asked, they will actually say, the question will ask you for the arithmetic mean. This simply means the average. Okay? So say I tell you to find the arithmetic mean of 3 and 9. Or it might say what number is between, 3 and negative 9. What number is between 3 and negative 9 in this sequence? The way you can solve for this is actually just taking the arithmetic mean. Arithmetic mean is what we've done since middle school probably. We add our numbers and then divide by how many there are. So we have 2 numbers, we add them, and then we divide by 2. And we end up getting negative 3. Now notice the difference is common. We have a minus 6, I should say, here. And this is also minus 6, so you could find the next term even if you wanted to. You could find the one before that now that we know what the common difference is. Okay? So if it asks for arithmetic mean, it's just the average. Or you can find the missing middle term that way. So now we are going to use all this. We are going to find the rule. So that's just the equation using this guy. And find the 10th term. So I'm going to go ahead and rewrite my equation down here. I'm going to use that a sub n equals a sub 1 plus n minus 1 all times d. Then I'm going to label what a sub 1 is, what d is, and what n will be eventually. Because for the rule, I want to leave n in my equation so I can solve for anything, okay? So a sub 1 is 2. We start with 2. Our difference here is plus 4, and plus 4. Okay, so our difference is 4. N will eventually be 10, but we won't use that until down below, okay? So I have a sub n is equal to a sub 1, which is 2, plus n minus 1 all times d. Notice how I did not plug 10 in there, because I want to leave it a equation, a formula, instead of solved. Go ahead and distribute 4 through, since I can't simplify within my parentheses. I combine like terms. Oops. And I have my rule. This is what's going on in that sequence. So now I can find the 10th term by plugging in 10 for n. I end up getting my solution to be 38 for my 10th term. All right, we do have another one like this. Go ahead and pause me if you want to try it yourself. If not, here we go. So we have a sub 1. That's our first term. That is 5. Our difference here is that we are adding 3, so it's a common difference. Our n will eventually be 14, but we will do that at the end. So our rule, we use the equation a sub n equals a sub 1 plus n minus 1 all times d. Gotta plug in a sub 1 and d. We can distribute and then combine like terms. So this is our rule, our equation. Now we can plug in a sub 14 and we end up getting 44 is our term. So instead of adding 3 to get to the 14th term, which you could technically do, it would get you your solution. It's quicker to come up with it this way. All right, lastly, we're going to write out the first 5 terms of the sequence, which means we're just going to plug in 1 through 5. So a sub 1 is equal to 5 plus 1 squared. A sub 2 is equal to 5 plus 2 squared. And so on and so forth. So when you solve these, you end up getting 6 and 9 and 14 and 21 and 30. So our first 5 terms are 6, 9, 14, 21, and 30. All right. That's all I've got for you. Have a great day.